A remarkable discovery found by the James Webb Space Telescope, JWST, has enthralled the public and scientific community alike, from a distance of about 7 trillion miles from Earth. It has picked up what looks to be city-like lighting. Discussions concerning the possible presence of extraterrestrial life have been rekindled by this surprising discovery. The telescope detected very brilliant lights coming from Proxima Centauri b, the nearest exoplanet to our solar system, which was the target of its observations. There is interest in the origin of these lights since they resemble artificial lighting that is commonly found in urban areas on Earth. Is this proof that intelligent life exists? Intriguing questions have been posed by the JWST's most recent startling discovery. Where might these city-like lights on Proxima Centauri b be coming from? Were they able to indicate the existence of alien societies? Both the general people and scientists have long stared at the expanse of space in the hopes of discovering evidence of life beyond our planet. There is a great deal of enthusiasm surrounding any hint of such discoveries. The discovery of what appears to be signs of life in the furthest reaches of space by the JWST has shocked scientists. Some speculated that there might be an extraterrestrial city in that star system when the telescope noticed strange city-like lights flickering from Proxima Centauri b, while sending data back to Earth. These lights seem to be coming from a far-off metropolis. This finding may point to the existence of sentient life and the possibility that, unknown to humans, highly developed civilizations are flourishing in space. Many people, especially NASA engineers, are intrigued by the discovery of city-like lights 7 trillion miles from Earth. They are now wondering how long these lights may have been there, possibly waiting for humanity to create the technology needed to detect them. According to Columbia University space specialist David Kipping, Proxima Centauri b is an interesting exoplanet. He points out that because it is the nearest star system to Earth, it differs from other planets in terms of temperature. The infrared emissions of Proxima Centauri b differ significantly from those of its host star, Proxima Centauri, in contrast to ordinary rocky planets that absorb sunlight and emit infrared radiation. For scientists looking to learn more about the planet's atmosphere, this observation is essential. The JWST has been able to examine Proxima Centauri b's atmosphere with unparalleled clarity thanks to developments in infrared imaging technology, providing fresh perspectives on the planet's capacity to support life. Most space telescopes struggle to detect even the smallest light in the great cosmic dark, but the telescope's remarkable infrared sensitivity enables it to study the planet's night side. The JWST, on the other hand, is constructed especially to pick up even the faintest artificial light emissions from far-off planets. It can identify any artificial light as long as it is within a frequency range 1,000 times smaller than that of stars. Notable is also the relationship between the surface properties and the celestial aspects of Proxima Centauri b. Numerous solar panels on the planet's day side gather energy from its star, and the spectral edge reflects incoming light to assist keep the planet's energy balance. Like Earth, Proxima Centauri b has alternating periods of day and night as it revolves around its star. The planet receives a lot of solar energy during the day, which causes it to cool down at night. The makeup of the planet affects the variations in its temperature. In the event that Proxima Centauri b is devoid of an atmosphere, the daytime temperature would be extremely hot and the nighttime temperature would be extremely frigid. Astronomers must comprehend these temperature variations in order to further investigate the planet's atmospheric properties. Through in-depth examinations of Proxima Centauri b's thermal emissions, scientists are using the JWST's sophisticated infrared imaging capabilities to gain important knowledge on the composition of its atmosphere. It's interesting to note that the JWST's orbit around Earth coincides with the orbital period of Proxima Centauri b, enabling researchers to watch the planet's day-night cycle every 7.2 Earth days. The next round of research will concentrate on examining Proxima Centauri b's chemical makeup in order to determine whether or not it has an atmosphere and can sustain life. Whether the planet is suitable for life or not will depend on important components like oxygen, methane, and water vapor. Determining these elements requires analyzing the light traveling through the planet's atmosphere, but even with the JWST, this is still a difficult task. Astronomers are eagerly awaiting the launch of future ground-based observatories, such as the extremely large telescope ELT, which is expected to start operations in 2028, but it can only observe a tiny fraction of the closest possibly habitable worlds. In order to provide vital information on the habitability of distant exoplanets, the ELT will concentrate on investigating their atmospheric characteristics. Meanwhile, the JWST is still a vital tool for expanding our knowledge of distant exoplanets. The JWST has enormous potential for making ground-breaking discoveries that will greatly advance our understanding of space exploration, notwithstanding its limitations. With an eye toward the future, astronomers are creating new space telescopes that will reduce the intense light that a planet's host star emits. This would enable more accurate research on exoplanet atmospheres and their capacity to support life by facilitating more effective study of the dim light reflected by the planet itself. This ambitious goal does, however, come with difficulties because scientists have to discriminate between gases that come from geological activity, such volcanic eruptions, and those that come from biological processes. As they continue to investigate the characteristics of exoplanets and look for potential evidence of life under their surfaces, astronomers are committed to overcoming these obstacles. The James Webb Space Telescope offers a preview of the amazing discoveries that will be made in the future and represents a huge advancement in the study of exoplanets. We are learning more about the universe's intricacies and our place in it as we carry on with our exploration. Researchers have been looking for definitive evidence of extraterrestrial life for decades, but they have not yet found it. As humanity continues to wonder if we are the only sentient beings in the cosmos, the hunt for extraterrestrial life continues. Scientists are depending on the James Webb Space Telescope to find possible extraterrestrial civilizations concealed amid the stars in order to address this age-old issue. In the meantime, there is a widely held belief that life on other planets might already exist and be only waiting for humanity to find it. Under the nonprofit CTI Institute, American astronomers Jill Tarter and Thomas Pearson began the Search for Extraterrestrial Intelligence (SETI) project in 1984. Analyzing astronomical signals for possible radio broadcasts from space is the main goal of this project. Unlike other types of radiation, radio waves may travel great distances without being absorbed or scattered, making them perfect for these kinds of searches. This characteristic increases the likelihood that the 42 radio telescopes that comprise the Allen Telescope Array in the Cascade Mountains of California will detect radio signals. No conclusive proof of extraterrestrial life has been discovered despite the SETI Institute's more than 30 years of monitoring these signals. Jill Tarter, however, is upbeat and has urged Earthlings to join the hunt for extraterrestrial intelligence. Following recent NASA reports that the James Webb Space Telescope has spotted city-like lights from a planet near Earth, the search for extraterrestrial civilizations has regained speed. Launched in December 2021, the JWST is the most sophisticated instrument available to humanity for investigating the secrets of the cosmos. Its state-of-the-art optical technology enables it to see through cosmic dust and discover the universe's mysteries. Its main goal is to investigate the formation of the first stars and galaxies, which occurred billions of years ago. The history of James E. Webb, a NASA administrator who was instrumental in space exploration and the Apollo moon landing program, serves as the inspiration for the Webb Telescope's innovative optical technology. A collection of cutting-edge instruments on board the James Webb Space Telescope combine to offer unparalleled views of the cosmos. These tools, which guarantee accurate placement in space, include the mid-infrared instrument (MIRI), the near-infrared camera (IR-CAM), the near-infrared spectrograph and IR-SPEC, and the fine guidance sensor (FGS). Its massive mirror, which is made up of 18 hexagonal pieces, is intended to capture the smallest light from the first galaxies in the cosmos. The telescope, which operates at very low temperatures, is able to pick up faint heat signals from far-off objects. The Webb Space Telescope has delivered on its promise since launch, revealing some of the oldest and most distant galaxies ever seen. Its potent instruments have yielded new information on exoplanet development, galaxy evolution, and star formation. An important turning point in humanity's quest for extrasolar life was reached when city-like lights were discovered on Proxima Centauri b. The Webb Telescope has undoubtedly opened a new chapter in our understanding of the cosmos and our place in it. Even though more research is required to confirm the nature of these lights, a renewed interest in alien life has been sparked by the continual detection of lights on Proxima Centauri b, which is 7 trillion kilometers from Earth. This discovery represents a crucial turning point in humanity's effort to comprehend the cosmos and highlights the remarkable powers of the James Webb Space Telescope. The telescope, which was launched in December 2021, has sophisticated infrared imaging equipment that allows it to see through cosmic dust and uncover the secrets of the cosmos. The Webb's capabilities extend much beyond its primary purpose of studying the birth of the earliest stars and galaxies. The possibility of intelligent life outside of our solar system is intriguingly called into doubt by the finding of city lights on Proxima Centauri b. Scientists and astronomers are highly interested in the ramifications of this discovery, since it may offer insight into civilizations that are flourishing in far-off regions of the cosmos. There have been intense discussions over the implications of this discovery for humanity's quest for extraterrestrial life due to the prospect of city-like lights on an exoplanet so far from Earth. The mystery surrounding Proxima Centauri b is of great interest to the scientific community as the James Webb Space Telescope continues to relay data. The answers could change our knowledge of life in the cosmos. The telescope's unmatched capacity to detect even the smallest light emissions, which may indicate artificial illumination sources, is among the most important features of this discovery. It would be one of the most significant discoveries in human history if these city lights are, in fact, the product of intelligent life, offering verifiable evidence that we are not alone in the universe. But it's not easy to determine where these lights are coming from. Before making firm findings, scientists must rule out natural events as probable causes and take into account other theories. The results from the Webb telescope highlight the significance of upcoming space exploration missions, in addition to the possible discovery of extraterrestrial life. The advancement of astrophysics is being pushed by the methods and technologies created for these telescopes. Future telescopes could provide even more detailed information about the atmosphere and habitability of far-off planets as developments continue. In addition to helping us better understand possible life, the capacity to detect feeble light emissions from distant star systems is essential for improving our techniques for identifying settings that host life. Astronomers intend to carry out additional research on planets such as Proxima Centauri b in the future, concentrating on their atmospheric characteristics and their capacity to harbor microorganisms or possibly more complex life forms. Long-held beliefs about extraterrestrial intelligence are called into question by the finding of city lights. As part of the SETI program, scientists have been looking for indications of life for decades, especially through radio waves. This discovery, however, raises the possibility that life could also be found by looking for signs of technology, such as artificial lights. This change in viewpoint may change how future searches for extraterrestrial civilizations are conducted, broadening the definition of what is considered proof of life in the universe. The James Webb Space Telescope will undoubtedly continue to be at the forefront of this pursuit as our knowledge of the universe advances. Its extraordinary powers have already started to expose shocking facts about the cosmos, and more research may turn up evidence of worlds far away that might support life or civilizations that are far different from our own. This finding is only the start of an exciting adventure in the ongoing hunt for extraterrestrial life. Future space missions will yield ground-breaking discoveries about our role in the cosmos thanks to advanced technology, worldwide cooperation, and scientists' unwavering curiosity. The James Webb Space Telescope will continue to be essential in supplying priceless data and deepening our knowledge of the wide cosmos as we search the stars for life. Scientists are currently debating the moral conundrums raised by the finding of extraterrestrial life. What is the best way for humans to communicate with sentient beings that are located in far-off star systems? What would contact with extraterrestrial civilizations entail for the future of humanity? As we approach the dawn of a new age in space exploration, these questions are becoming more pressing. The discovery serves as a reminder of the enormous potential that the universe holds, inspiring further investigation, creativity, and awe. Even though much more work is required to confirm the existence of city lights on Proxima Centauri b, the motivations behind humanity's ongoing search for cosmic understanding keep us moving forward. The search for knowledge is still one of humanity's greatest pursuits, regardless of whether these lights prove to be signs of extraterrestrial civilizations. The exciting discoveries made by the James Webb Space Telescope, which will play a significant part in determining the direction of space research in the future, have raised hopes for the discovery of extraterrestrial life. More incredible discoveries will undoubtedly come from space exploration, regardless of whether we find sentient civilizations or strange occurrences. As scientists put in endless effort to solve the universe's intricate puzzle, the puzzles surrounding the genesis of these enigmatic city lights will continue to drive scientific investigation for years to come. In conclusion, the James Webb Space Telescope's detection of city lights on Proxima Centauri b marks a significant advancement in the hunt for extraterrestrial life. This discovery demonstrates the telescope's extraordinary powers and provides a fascinating look at the possibility of uncovering highly developed civilizations that are far different from our own. The enthusiasm surrounding the potential existence of extraterrestrial life will only increase with each new discovery as scientists continue to examine the evidence and consider the implications of this finding. One of humanity's oldest and most important questions, are we alone in the universe, is getting closer to being answered. With the James Webb Space Telescope at the forefront, we will be able to explore the vast unknowns of space in previously unthinkable ways as we embark on the adventure to unveil the secrets of the cosmos. Regardless of whether we come across extraterrestrial civilizations or discover new life forms, the Webb Telescope's revolutionary work will surely usher in a new era of exploration that will influence space travel for many years to come.